Hi, this is Dr. S. Dhanambar, belongs to Kungunadu College of Engineering and Technology. Today we will discuss about the stack and queue operations. First we will discuss about the stack with the definition and one. Stack is a linear data structure which follows a particular order in which the operations are performed. The order may be lost in first out manner. Okay. Then linear data structure have two important types. One is a linear data structure and another is a non-linear data structure. Under the linear data structures, we have two important concepts. One is the stack and another one is the queue. These both are the very important concepts belongs to linear data structure. And another one is a non-linear data structures. Under the non-linear data structures, we have two important concepts, tree and graph. Now we will discuss about the stack and queue under the linear data structures. Okay. The linear data structures stack is a simple this concept is a last in first out manner. It's followed by a last in first out manner. What do you mean last in first out manner? The first you can insert the element to the stack, then finally or last you can retrieve the data from the stack. It's called as a last in first out manner. Take a simple example. There you have rack 1, 2, 3, 5, one by one all the racks. Okay. If you want to insert the data, first rack is the first position and is the second position, is the third position, fourth position, fifth position, one by one. Then insert the data is called as a push to the data into the stack using a top position. Okay. If you want to push the data and retrieving data from the stack using a pop operation. Okay. Then retrieve the data is a very you can retrieve the data using a last retrieve the data. First you inserted the data, first you push the data, you retrieve the data or delete the data from the stack in the last position. It's called as a stack operation. Then inserting and deletion happen on the same end. What do you mean same end? Here you have only one position. That position name is a top position. Whatever it may be, you can do any operation using a top position. It's called as a small definition with the example of stack. Okay. Then operations of stack. The stack following operations are performed in the stack. Stack we have three important operations. One is the push operation, pop, and another one is the display operation. Push is nothing but to insert the element onto the stack is called as a push operation. Then pop is nothing but to delete an element from the stack using a pop. The display is nothing but display the data from the stack using a display operations. These are the important operations we have under the stack. Conditions on stack. There are two important conditions followed by the stack. One is a condition stack overflow and another one is a stack underflow. What is stack overflow? A stack overflow is an undesirable condition in which the program tries to use more memory space than the call stack has available. Okay. Stack overflow is nothing but just to take a simple example, you have a five memory location. Here you have a five memory locations, five memory locations into your computer using a stack. The first location is you have data is a 2, the second location is a 1, and third location is a 7, fourth location is a 1, and fifth location is a just empty. If the fifth location is filled means it's not possible to insert any another one data into the stack. It's called as a stack overflow. Okay. In the stack overflow, it's not possible. If the stack is overflow means it's not possible to insert the any another element to the stack. It's called as stack overflow. Then another concept is stack underflow. Stack, if the stack is empty and yet a pop operation is attempted, then its result in the stack is underflow condition. Or underflow means if the stack is all the positions are empty. Okay, take a simple example: is the five memory locations. The first location is empty. Second location is also called as empty. Third location is also called as empty, and fourth location, fifth location. All the locations are empty. Means it's not possible to remove or pop operation is not possible. So at the time the stack is underflow. Okay. This is a small definition of stack overflow and underflow. If the stack is empty and yet the pop operation is attempted, then it's result stack underflow condition. Okay. Then if the insert the element using a condition is stack overflow, and check the stack is overflow. Whether the stack is overflow means it's not possible to push the any data to the stack. So it's called the stack overflow. What is stack underflow means? If you want to delete the element, if you want to take a pop operations attempt, at the time the stack is empty means it's called as a stack is underflow. The implementation of stack. In implementation of stack, we have two important implementation of stack. One is array implementation and another one is a linked list implementation is possible. That stack implementing can be done using array implementation. Now I will explain to you under the stack array implementation. Array is a static data structure, so the collection of data must be fixed in size. The only problem with this implementation is array size must be specified initially. Take a simple example. Here, just array is a static data structure, so the collection of data must be fixed in size. Array is a static memory location allocated method. If the data size and the locations are fixed, it's not possible to insert the above the allocated memory location. The only problem with the implemented the array size must be specified initially. The stack maximum size only possible to insert the elements. And take a simple examples. Here the 5 memory locations or 6 memory locations. Only maximum 6 element is possible to insert the push the data into the stack. Okay, it's called as a stack condition using a static methodology. Take a simple example. I will explain with the concept of stack operations, with the push and pop operation, display operation, everything I'm going to explain with you with a simple example program. Okay. First one is the input standard input output header file. Next one is header file is a standard library header file. These both are the header files used for the purpose of the scan of printf and everything. The next one is the integer stack allocated the memory locations. It's a static memory allocation. Stack memory location is 100. Then next one is a variable declaration for choice n top x comma I. These are some other important variables are declared. Then you have a 3 important operations we will discuss in this program. One is a void push, void pop operation, and another is a void display operation. Let's move to the main function. If the top equal to -1, okay, if the whenever you want to insert the push the data to the stack, before that the top position allocated the top position into the program. The top equal to -1. In this -1 means not possible to insert the -1 memory location to the element. So top equal to -1. Printf enter the size of the stack, maximum equal to 100. Scanf percentage of t ampersand of t. Get the value from the how many elements you want to insert to the stack. Okay, is again. Suppose the next one is the stack operation using array. Then insert the you have a these are the printf statement used to display the display the data in the output screen. Okay. There are 3 important operations. One is the push, pop, and final one is the display, and fourth one is the exit operation. Loop condition that printf enter the choice. Whether your choice is 1 means just move to the push operation. Whether your choice is 2 means move to the pop operation. Your choice is 3 means move to the display operation, and 4 means exit point. Is the end of the statement or end of the program. Okay. Default printf please enter the value choice. Whether you can check the value points, the statements are choices are 1, 2, 3, and final answer 4. While choice not equal to 4. Okay, whether if the choice is above 4 means just written automatically exit the statement. First one is a while. Suppose my choice is 1. Okay, the choice is the case 1 choice is 1. 1 means push operation. Then move to the push operation if top less than equal to n-1 means then stack top is greater than n-1 means stack is overflow. It's not possible to insert this nothing but the push the element to the stack is not possible. So at the time automatically move to the stack is overflow and exit the statement. Okay. Then otherwise you can insert the element one by one using a top position is increment 1 by. If the top position is, suppose let's take a simple example. I want to insert the element 5 elements I want to insert to the stack. The array locations are 5. Now the top position equal to -1 means just you can just move to the increment the top position, top plus plus 1 plus plus means -1 plus 1 equal to 0th location. Top position is moved to the 0th location and insert the element new element x equal to 10. The stack top position 0, the 0th position insert the value of x 10. Okay. The next one is the next operation is the void pop operation. Pop operation is nothing but this called as a delete the element from the stack. Okay. Using the first use condition top equal to less than 1 means the stack is underflow. The stack is underflow means it's not possible to delete the any element from the stack. So first you can check whether the stack is underflow, otherwise you have some other element in the stack. Okay. If stack is below -1, below 0 means if the stack is underflow, it's not possible to delete the element. Otherwise you can move to the pop the element, then move to the delete the first position on the top position. Okay, this is called as a stack pop operation. The next one is a while display operation. If the top greater than equal to 0, greater than, just assume as assigned as a greater than or equal to 0 means you have some other element in the stack. The stack have some other element in the position. So you display the data one by one using a top position. If elements in the stack, if top equal to top, then it display the one by one all the element in the stack. This is followed by the last in first out manner. Okay, other is first in last out manner. So first you can insert it or push the data, the lastly displayed. Okay, the last inserted data displayed to the first position on the stack. Okay, otherwise the stack is empty. Okay, this is a simple example using a stack. The next one is just I'm going to explain the next concept, the queue abstract data type. Okay. It's called as a linear data structure. Inserting a linear data structure. So another important type is a queue abstract data type. It's called as a linear data structure. Inserting occurs only at the one end is called as a rear position. Deletion occurs only at the one end is called as a front positions. Elements that is inserted first is deleted first. Okay, this is followed by the first in first out manner. In this, just see this simple example graph diagram. They have a two positions. One is a front position and another one is a rear position. Front position used to delete the element. Rear position used to insert the element. If you want to insert the element using a rear position, if you want to delete the element is using a front position. Here you have only the followed by the first in first out manner, otherwise last in last out manner. First you can insert the data, you retrieve the data from your database using the first positions. So this is the first in first out manner followed by it. Operations in queue. There are the few operations followed by the queue. Inserting an element into the queue at the rear position is called as a N queue. It's an insert queue is called as a N queue. Deleting the element from the queue is called as a D queue. Okay. Exceptional conditions. There are the two important conditions. One is the overflow condition and another one is the underflow condition. Now, what the purpose we are using a overflow and underflow condition. Overflow condition used for whenever you want to insert the new element at the rear position. First, you can check the queue is overflow or not. Whether the queue is overflow means it's not possible to insert the element to the queue. So you can check the overflow condition. Suppose I want to delete the any element from the queue. First you can check the whether you have any element in the queue or not. Whether you have any element, then only possible to delete the element from the queue. So it's using for the condition is the underflow conditions. So simple example I'm going to explain to you array implementation of queue. Okay, NQ operations. Here NQ operations is nothing but insert into the queue operation. Okay, insert is just a function name is a NQ rear equal to max minus 1. Okay, maximum minus 1. The rear position equal to maximum minus 1 means listen. Here you have a rear position. Just I allocated the I want to insert the number of element equal to 5. I inserted the element 0th location 10, first location 20, and second location 30, and third location 40, and fourth location 50. I inserted the 5 elements in the queue. Now the check the condition. I have allocated only 5 memory locations. Already all the locations are occupied, and now it's not possible to insert the any one data to the queue. First, you can check the whether the any queue positions are empty or not using this statement. Okay, if rear equal to max minus 1, maximum equal to fourth location, condition is true. The condition is true means just insert queue is overflow. Otherwise, else if here else if front equal to minus 1 and rear position equal to minus 1, you are not having any element in the queue. The queue is empty at the time front equal front and rear assign as a 0. 0th position, insert the front and rear position is 0. and the 0th position we can insert the new element. Just I inserted the new element 12 in the positions. Okay. Now else real plus plus. Suppose I want to insert the another element. Okay. At the time already have a front position, rear position, both are in the 0th position. Now increment the rear position, rear plus plus. The rear position is automatically moved to the, just insert the 25 in the first memory location, and rear position automatically move to the next positions. Next, okay. Next array implement. This is the simple example for front and rear position. Front position, now front position is 12 and rear position is 25. Now I want to insert the another element. The second memory location is the second, third and fourth position are empty. So now I want to insert the another element. Rear position is increased one position, then move to the second position, insert the another element 35 or 45 or anything. Okay. It's up to end of the memory location. Then here array implementation queue using a deleted operations. Deleted operation, first you can check whether that if you want to delete any element, you have some other element in the queue, then only possible to delete the element in the queue. So you can check whether the positions are empty or not empty. Whether the is called as a queue underflow, otherwise you have a some other element in the memory location. Using this statement, if friend equal to -1, friend greater than rear position means the queue is underflow. Okay. Now front, otherwise value queue front position is deleted position. Okay. Now here you have a two position. Front position is called as a 12 is the front position. Next to 25. Now 1 by 1, increase the 1 by 1 and delete the element. Now front position is removed. Front 12 is removed. Then front position move to the next position 25. It's called as a, and free the front position first to 0th location and move to the second location. It's a queue deleted operations using queue. Next one is a display operations. Display operations is whether you have two important operations. If you want to insert the element means using a, if you want to delete the element means using a check the condition is underflow or not. Whether the queue is underflow means not possible to delete the element in the queue. At the same condition you can use in the display operation. Whether the queue is underflow means not possible to delete the element in the queue, so it's called as the queue is underflow. Okay. Using statement front equal to -1 and front greater than rear means automatically queue is underflow. Another statement, if you have a one statement is front equal to -1 and front greater than rear is one statement. Another statement front equal to -1, front is a rear position equal to -1, the queue is empty, queue is underflow, it's not possible to display any operation, the automatically display the printf queue is underflow. Okay, otherwise move to the next one is the front I equal to front I grade increase the one increment the 1 by 1 front position and display the data 1 by 1 all the positions in the queue. Okay, this is the simple example. Front positions, front position equal 0, then rear position 4, that's inserted display the 1 by 1. The next one, another important concept you have a queue is called as a double-ended queue. Double-ended queue is a DQ is a two types. Okay. Double-ended queue means here the first we discussed about the normal queue, okay, linear queue. In this linear queue you have only front and rear position based on the insert or delete using a front position or rear position. If you want to delete the element means using a front position. If you want to insert the element to the queue means using a rear position. It's called as a linear queue. Now double-ended queue is nothing but, so double-ended queues you have two types. One is the input restricted DQ, and another is output restricted DQ. Okay, what is input restricted DQ means if the inserting is only one position, but deletion is have possibility in the two positions. It's called as an input restricted DQ. We take the simple example: inserting at the only one end, deletion at the both ends. Here see, we have the elements are 34, 12, 53, 61, 9. The rear position only possible to insert the element in the only one position, but deletion is possible in the two positions, both positions, front position and rear position also deletion is possible. Is called as a input restricted deleted queue. The next one is output restricted deleted queue means here you have a double-ended queue. This inserting is possible in the two positions, but deletion is possible only at the front position. It's called as a double-ended queue. Okay. Just these are the important contents we are discussing in today's session. Just go through all the topics. Then first we will discuss about the stack with the definition. What is stack? What is the purpose of stack? What are the important operations you have under the stack? Push and pop operation we are discussing about the stack. Then operations are three important operations: push, pop, and display operations. With the two conditions, one is a overflow condition and another is underflow conditions. Then implementation of stack, array implementation of stack. Just I will explain with the I explained with the small concept with the statements. Okay. The next one is a queue. Under the queue, you have a linear queue and the priority queue, double-ended queue. But today's session we are discussing two important queue methodologies. One is a linear queue and another one is a double-ended queue. In this linear queue, you have only the insert the element to the rear position and deletion element in the front position. We will discuss with the operations and the two important conditions. One is the overflow condition and another one is the underflow condition. We will discuss under the operation queue. Then a simple take array implementation of queue with the two important operations we discussed: insert queue operation discussed and the deletion queue operation are discussed. Next chapter we will discuss about the double-ended queue. Double-ended queue is nothing but is a uh, input. Double-ended queue means we have a it's possible to input double-ended queue have a two types. One is the input restricted DQ and another is output restricted DQ. Input restricted DQ you have only inserting is possible on the only one person, but deletion is possible on the both ends. It's called as input restricted DQ. And output restricted DQ you have inserting is only insert is possible in the both ends, but deletion is possible in the only one point. It's called the double-ended queue. Okay, these are the important topics are discussed in today's session. Thank you. Thank you to all.